Dear friends, once again we welcome you here in the video series of televisioning subject. Every day you are watching the television in your house, but have you ever realized that how this picture is formed on the television screen? Therefore, today's topic is picture synchronization. In the picture synchronization, we will discuss the all aspects of picture formation at the sync level as well as the picture level. If you see this diagram, you will see that how the picture reaches toward television screen. Here in this figure, picture reaches toward TV screen by two ways. First, by a cable in which the picture is picked up by TV camera and the sound is picked up by microphone. After amplification, this sound reaches to TV screen along with the video signal and form the picture. In the second set, picture transmitted from thousands of kilometers from television and signal reaches to antenna facing the several headends of the atmospheric condition, dust, temperature, cloud and heat. Even then, picture is formed on the TV screen. It is same as it is transmitted from television transmitter. This shows that along with the picture some more information is sent, and what is that information we will discuss here. Let us take one example here. This is the TV screen and we have a color picture. In the color picture, this face is of a smiling one and this face is of weeping one. If we divide this screen into 20 strips and instead of arranging the strips in systematic order, this order is changed and you can see what types of picture is formed on television screen. In the similar way, you can realize that the TV screen which has 625 lines, and if these lines are not formed at its own place according to the transmitter, you can imagine the type of picture may appear on TV screen. Therefore, let us open one television and find out the place where this video signal is available. We know that the television has RF and AF stages. Video signal is available after video detector. Therefore, we have to first search the video detector stage in the TV. this video signal, which is composite in nature, is available at the video detector stage. The video detector detect the video signal and send to video amplifier. This video amplifier is required to raise the video signal level, so that synchronizing pulses coming from the sync separator may have the level which can lock the horizontal and vertical oscillator. If the amplitude of video signal is not of enough amplitude, your sync separation may affect. In this video amplifier, the signal is sent to various stages. One is AGC, also called automatic gain control. Other is luminance, which is related to black and white picture. Another area is chrominance, which is related with the color signal, and last one is the sync separator. If you watch this skin, you find there is a difference between video signal at the input of video amplifier and at the output. We know that any amplifier adds a 180-degree phase difference between input and the output signal. That is why the input video and the output video are out of phase, and after sync separator, the composite sync is taken out. The composite sync means it has horizontal and vertical components. These horizontal and vertical components, after integration and differentiation, are sent to horizontal and vertical oscillators. These horizontal and vertical oscillators make the picture on television screen. The composite video signal on the television screen in the form of video signal is available on the oscilloscope, and this signal has been taken from the video detector of a television. This is the sync and corresponding picture. The same composite video signal which was available on the oscilloscope has been shown again here, but in the graphic form. If we see this composite video signal, which is called color composite video signal, has two parts. One is this part, which is non-visible region, and another is this part, which is the visible region. The duration of non-visible region is 12 microsecond, and the duration of visible portion is 52 microsecond, and the signal which is shown here in this form is of a particular picture. what is that picture? Let us see here. This picture is color bar, and these colors are white, yellow, cyan, green, magenta, red, blue and black. The composite signal and its corresponding picture we have seen here. The color composite video signal, since it is composite, it means it has two parts. The first part is luminance signal. It is also called Y signal. The second part, which is called chrominance signal, is also known as a chroma signal. It means the color composite signal consists of luminance and chrominance components. Here, this is the wave shape of a luminance signal, and corresponding chrominance signal is here. Color composite video signal is formed by superimposition of chrominance signal over the luminance signal. That results in a color composite video signal. These luminance and chrominance signal forms the color composite video signal. We back to again on television, and this is the corresponding color composite video signal shown on the screen of the oscilloscope. The corresponding colors are also mentioned here. The sync and the color burst along with the blanking signal is also shown. The position of sync, burst and blanking corresponding to color strip has been shown. This was about the visible portion and color composite video signal. The other portion, which is non visible, is called the black burst or the BB signal. This contains the sync pulse of 4.8 microsecond, color burst of 2.5 microsecond and blanking signal of 12 microsecond. These are the durations of the pulses available in black burst. But what is the type of wave shape? The wave shape is of this type. The position of horizontal sync is here, color burst is here, and the blanking pulse is here. The duration of blanking pulse, this one is 12 microsecond. Duration of sync pulse is 4.8 microsecond, and duration of color burst is 2.5 microsecond, and they have been arranged according to their timings. Let us see here again this color composite signal. The signal which is blinking correspond to the color bars, and now the black burst signal is this one. Let us see here once again this signal. This is the signal corresponding to the color bar available in visible period or visible region of television screen, while this color bar is blinking correspond to the visible region. The non visible region during the blanking period is black burst. So, let us see the composite sync. The composite sync consists of horizontal frequency of 15.625 kilohertz, vertical frequency of 50 hertz. This is the wave shape of the black burst signal. Out of the composite sync pulse, only horizontal sync pulse is available here. Then where is the vertical sync? The position of vertical sync is different compared to the horizontal sync. This was not the condition in case of horizontal sync. The vertical sync has been put in a safer position. To safeguard the vertical sync, pre-equalizing and post-equalizing pulses has been added. You might be thinking, what is the need of these pre-equalizing pulses and the post-equalizing pulses? If horizontal sync can go without pre and post equalizing pulses, then why not the vertical sync pulse? The sync pulse level is maintained at 25% of the composite video signal, and it is independent of the signal content or the signal available on the TV screen. It has nothing to do with the picture on the screen. The sync is in non-visible region, so will not affect the visible region. Let us see here where is the sync. We have opened a color television and we are trying to find out where this sync is available. We know that the composite video signal is available at the video detector. Therefore, this composite video sync we have found from the video detector, and this is the shape of a composite sync along with blanking signal. What is the precise synchronization? We have been talking about the horizontal and vertical pulses, whether these pulses synchronize the horizontal and vertical oscillators. Certainly, but what is the precise synchronization? We know that television has the interlace scanning. In the interlace scanning, during the scanning, the beam starts from the center of TV screen and ends to the one corner. And during the vertical sync period, this spot move to the beginning of the television screen and start the scanning. We have also studied that in scanning, the beam starts from one end and reaches to another end. It takes 52 microsecond, and within 12 microsecond the same beam return to its original position. But in case of vertical sync, this is not so. The time taken by the spot to reach from end of the TV screen to the beginning of TV screen frame, it takes 160 microsecond. There is a big difference between horizontal sync retest period and vertical sync period. In 180 microsecond, what will be the position of horizontal oscillator? Whether it will remain in the control or it will go out of synchronization. Certainly, if there is no control on horizontal oscillator, it will slip from its synchronized position and picture may not form on TV screen or create the disturbances during the blanking period. Then what is the remedy for this one? We add vertical sync in serrated form. Serrated form means the vertical sync is cut in the multiple of horizontal pulses. And these are arranged in systematic and serrated form. Let us see here again the shape of vertical sync and its position. In the figure, this is the vertical sync. The total duration is 3 horizontal line or 160 microsecond, and it has pre-equalizing and post-equalizing pulses. The vertical sync is not of equal duration, it has been sliced into 6 parts, and these are the part of horizontal sync. So that the horizontal and vertical oscillator oscillates in synchronized form, and these equalizing pulses maintain the voltage level at the vertical sync in a systematic order, so that vertical oscillator may not shift from its position. When we say the pulse structure, what it means? We have discussed and told that during interlaced scanning, the even lines and odd lines are scanned separately. The field of odd lines is one field and the field of even lines is another field. Therefore, a TV screen contains the two pulse structure, one of odd lines, another of even lines. You see that this wave shape is same as shown for the vertical pulses, but what is the difference? The difference is at the start of a field, whether it is odd field or it is even field, and this is decided by the half line pulse available at this position, which clarify the exact field transmitted from the transmitter and to form the picture at its exact position.